So here we're going to pick up a topic of what's called the cross product. Now the cross product can also be known as the vector product. So it could be called either or. Now we noticed in our last video when we started talking about vectors and we introduced the idea of the dot product or the scalar product. And that's because we get a scalar answer. We just get a magnitude as an answer, just a number. Whereas here with the cross product or the vector product, we are going to get a vector as an answer. So we're going to get it in terms of an I, j and k coordinate. If we take an engineering example, okay, we're going to look at the force as a vector is given as 2i plus j minus k. We're going to say we're working out in a radius. A distance along our 3D plot is going to be I plus j minus 2k. Well, if we want to find the moment of this force and its magnitude and its coordinates, we're going to say the moment equals or times f. And this here represents the cross or vector product. So it's represented with an x, as opposed to when we see the dot was represented with a dot. So how does this relate to matrices? Well, to get M, okay, what we do is we set up a determinant matrix, and it's going to be a 3 by 3. So we set up our straight lines to represent the determinant, and we put in I, j, and k, and again we have a straight line. And what we do is then we take each of the points, so we're doing or times f. So we take each of the points. So what's the I point? Well, it's 1i. So we put 1 in here, 1j, so 1 under the j, and minus 2k. So we just set up that row there. So our first row, we just automatically put in I, j, and k. Our second row, we take the first thing that we're multiplying, and we just put in, well, how many i's we got? We got 1 underneath the I, j, 1, and minus 2 over here. And we do the same for the f. We know we have 2 i's, we have 1j, and we've minus 1k. So this will help us calculate the cross product. Now what the cross product does is we get a vector answer. So our answer is going to be something multiplied by an I component. Then we're going to have something times a j, and we're going to have something times a k. What we're actually doing, we're trying here to find the 3 by 3 determinant of this 3 by 3 matrix. And we haven't looked at that, we only looked at 2 by 2. But what we do is we split it into little 2 by 2 matrices, and we work out the determinant from that, and we add them all together. Now the only thing, it follows a particular pattern. We're always going to have a minus j here. Everything else is going to be plus, but you're going to have a minus there. Okay, so that's just important to note that there's a minus coming in. So we'll try and highlight that there, that minus. So it's plus the I and minus the j plus the k. And okay, we set up our little 2 by 2 vector determinants. So how do we do that? Well, first of all, we're looking for the I one. So what you do is you block off everything where I touches. So you block off this row and you block off this column. And you get left with this 2 by 2 matrix. Then to find the determinant of that, we know you multiply the main diagonal and subtract the other diagonal. So you'll have 1 times minus 1, which will be minus 1, and you minus the product of the other diagonal, which is minus 2 times 1, which is minus 2. You do the same for the other, and I'll try and do it in a different color pen here, light blue. For the j, you eliminate the column and row that has j involved in it. So j is going to be comprised of this and this. So there's your 2 by 2 matrix. Again, you multiply along the main diagonal, you get minus 1, and you minus the other product of the other diagonal, which is minus 2 times 2, which is minus 4. And then finally, I'll do another color. We're actually running out of time in this video, so we'll pick it up in our next video.